Alright, hello everyone. Today we're going to be talking about the Caesar's algorithm, Caesar's Cipher. So, Caesar's Cipher came about when Julius Caesar needed a more discreet way of getting his salad from place to place. And unfortunately, this led to a rap battle between Caesar and the head chef of the establishment. And in this rap battle, Caesar had to lay down some cold bars, and that's how we get Caesar's Cipher. So, the first thing we need to do is establish an arbitrary number where we shift from place to place. Alright, and then Caesar used 3 as an arbitrary number, so we will also use 3. Step 2 is, in the instructions for my class at least, we have to make a string without any spaces. So we have to make the string that has spaces inside make it not have spaces. So, remove spaces. I have to sneeze also, so let me do that. Was not able to sneeze, but I found friendship, so that's even better. Step 3 is we encrypt this. So, using this arbitrary number, we shift the letters from one spot to the next. And that's how Caesar encrypted his messages. Step 4, we print. And then step 5, we will decrypt it. Meaning we'll shift it back using the 3. So without further ado, let's get the first shit started. So first things first, I'm the realist, but the second thing is we need to define a main. So, first thing we want to do, we want to define what arbitrary value we're going to shift everything. So I'm going to call this variable shift, and I'm going to set this to 3. The second thing we want to do is create a string that we're going to remove the spaces from. So in here, I'm going to do, this is according to my class, so I'm going to put do not pass go. And then we want to create a function that takes off the spaces. So let's do that right here, right above it. So space remover. This will take in a string. So I guess this isn't C++, primitive Ali. So this takes in a string. And this is very, 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 very simple. So what this is going to return is a string that dot replace. We're using the dot replace command. And anytime we see a space, we tell Python, no more strings allowed for you. So what we can do is we can do pt is equal to space remover. And then we put pt in there. That's just passing it by reference. So the next thing we want to do is make it so that we encrypt something. So let me look at that real quick, and yeah. Alright, so what we want to do is we want to define a function that takes in 2 parameters. The first parameter is going to be the string that since this is called PT, I'm going to call this cruiser. The first parameter is going to be the string, and the second parameter is what the shift is going to be. What I'm going to do now is make a new string. I'm going to call this new PT. And I'm going to set that to just an empty string. And let me put a comment. Empty string to add letters 2. Because in Python, strings are immutable, meaning that I can't really change it. But I can add things to the string, so I don't know how immutable that is. In any case, I use a for loop. For I in range, we want to use the length of the original string that we passed through. Semicolon, so that's I in range, however long this is. So that means that'll iterate for however long cruiser string is, and the cruiser string is literally this do not pass go. So what I want to do is I want to increment, and I can do that with the plus equal to, which I can use for strings. I think that's pretty fucking cool. So this is where I don't know what the fuck I'm doing, but I know what the fuck I'm doing. Oh, shit, actually, no, that didn't make any sense. We're going to use the character ORD function. So we're going to use character, and we're going to use ORD. Let me fucking Google this shit real quick. Okay, so I just Googled it, and the character method returns a string representing the character whose Unicode is point and integer. So I'm pretty sure, and then the ORD converts the character into its Unicode value. So what I'm thinking is happening is it takes the character, it converts into an integer, and then it converts that integer into a character. But I could be wrong, as I usually am. So what we want to do is pass in the cruiser. But we can't put in the whole fucking cruiser, right? We have to put in the ith position. Because we want to look at the first value. And then we want to append that to the new PT. We want to look at the second value. And then we want to put that into the new PT. And so on and so forth. The only thing different, the only thing that we're going to add on next to this is we're going to add our shift component. So this adds 3 to the ORD. And then the ORD gets converted into a character, and that's what's gonna get appended to the new PT. So if this was the letter A, then A, B, C, D, the shift would put it to the D value, and then this ORD would convert it into a number. Let's just say it'll convert it to 4. And then character would take that 4 and then convert it into a character and then append this to new PT. At least that's my understanding. And then what we can do is we mod that by 26. We mod this by 26 because of the fact that we have 26 letters in the alphabet. So modding it basically means that you get the remainder of whatever the 26 value is. You get the remainder, and then that becomes whatever the character is. That's just how I interpret it, at least. And then we want to return new PT. So what happens after that is we can... Oh, let's call main first before I look like an idiot. Let's print out PT. And let's see what we get. Run. Name PT is not defined. That's pretty cool. And that's also because I used the wrong name. So it says do not pass go. That means I fucked up royally. So, oh! Haha! Wouldn't be a video if... Wouldn't be me making the video if I didn't make any mistakes, and I made another mistake. Oh, Lord! I, for whatever reason, didn't even make sure that I put the equation in here. So PT will equal a new variable called encrypt, or we're basically calling this function. I don't know why I said we're going to call it a new variable. Apologies for that. So then we're going to put PT inside of here, and we're also going to put the shift value also here. This puts PT, and it equals that to that. So then we run this, and we get... That's all fine and dandy, but how the fuck do I change this back? And that's what we're going to get into next. Actually, you know what? I don't even know why I paused the recording. I can just do this shit right now. So, if I do definition decrypt, we do the exact same parameters. We can if we want, you know. Like I said, this is a free country. New... Alright, you know, let's call this the old PT because we're changing this back. For I in range, we can do the exact same thing, right? Range the length of the cruiser. And since we're using the same exact length of the string, it doesn't really matter. This is where it gets interesting. This is like, you know, you basically earn your degree after learning this. Whoa, I did it so fast, I should probably get a computer science degree by this point. What I just did was... Instead of adding, I subtracted. You remember how earlier in the video I said, if you add 3 to the letter A, you go all the way to D. This goes from the letter D, and you subtract 3, and you go back to A. And that's exactly what happened. And now all we have to do is return new PT. And just like that, we make a man out of you. Okay. So let's go decrypt. And instead of PT, instead of cruiser, we put PT. And then we print PT. Run. Dun, na, 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 na. Oops. Oh my god. Hold on, let me figure out what was wrong with it. Why do I do this to myself? See, I always tell myself, don't teach an old dog new tricks. And yet I'm trying to learn everything in the book, but I'm not doing anything. Alright, so we successfully convert this. Let's do it like this. Print PT. That way we see the starting, which is do not pass go, into Grakurskara, and then we go back to do not pass go. Alright, less than 10. Oh, fuck, that's 11 minutes. All that's left to do at this point is to do the pseudocode and shit like that, so, yeah. So, yeah, have a great day.